are student ambassadors,
Okay.
and a few of them are participating in the jam, and few are not, and few are there to learn more about like how the game optimization works, and they just want to work on that. And Akash did a session yesterday onto the VR kite simulator, so he's working on it. And I think I shared you the
Great.
screenshot, so he's there. Aman has been a student ambassador, and we named him Floater because he has been constantly floating in Unites. So if you are like with him,
Okay.
in a fraction of second, he will be floating somewhere else. So you won't find him again. So that's Aman.
Akash, I
Uh,
really love the lighting of your scene, what you have been doing for the kite simulation, and I also shared it with my team at Unity. Even they loved it.
and Aman is there, and Shivam is also a great developer. Pulkit is also a great developer. He works like mostly
Great.
with like games, game mechanics. Ayush, Rohan, both of them
Okay.
are student ambassadors again. So yeah, so I think most of the people who are here are mostly from the programming background and lighting background, like artistic background. So it would be a good thing for game optimization if we talk about.
Great, 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 great. Okay. So let's start the session, guys. So we can begin with 10 participants, minus
Yeah.
one without me. So what do you understand about game optimization as a big question? And often you'd find a lot of myths circling around when you start uh, developing your games. I have some mic issues, so that's why I'm not able. No problem, no problem. Yeah. Okay. Uh, so what I was saying is, when you start developing your game, your optimization should be like soul of your design. Uh, when you design games, optimization has to be a part of it. You cannot go let like you cannot go on like developing and then plan the optimization later. Uh, we have some more participants joining
Yeah.
in. Should I
Yes.
start later or should I continue?
No, you can continue.
Okay, okay, okay. Uh, so yes, as I was saying that you have to design your game keeping optimization in your mind. So it is really important to know like a few techniques. I'm not going to discuss like very advanced stuff about optimization, but this is something that you should be following uh, to get fair results from your game or when you're making a game with Unity. And this is not only applicable for games. This is also for a graphic artist. It is also applicable to the ones who are like building a movie, making a movie, or shooting a scene, and all of that. Anyways, so the first thing that you have to keep in mind is that you have to keep it simple. The approach has to be very simple. You need your design should be like must be able to know what you need and what you do not. You have to when you are making a game, you have to be very very careful and honest with yourself, uh, with knowing what you require and what you do not require. And you have to be bold with it to discard it if it is not useful in your scene. Okay. And how many of you are like good with the profiler, like just a general use?
We don't have any comments in the chat as well. So very few, I'd say, because we got two comments and they both are saying not much. So Vidip have used it a few times, and yeah. As I was saying, not a lot of people are familiar with it.
Sorry, my microphone was like causing some issues. Okay, you'd be interested in learning it, not very familiar. Okay, not an issue. About others as well. If you are not like have been using the profiler, it's always like great to learn. And the profiler is like your lighthouse. The profiler is your lighthouse that will guide you where it is causing problems, and it can like give information about the spikes that are coming from graphics issues, from scripting issues, from if there is something wrong with setting up the physics, and like what is that major peak you need to note about your game. And let's start with some basic uh, concepts of Unity. So can you see my screen now?
Yeah.
Yeah, you can see. So whenever artists and game developers are making objects, it's like a fair amount of like it's the whole scene is like completely filled with like objects and stuff. And when you're modeling these objects, artists prefer to like model it as separate objects. So like most of the times you miss about like uh, keeping optimization in your mind while designing the game. So imagine you're like building a city. So a city is a big model. A city is a big model with a lot of objects around in your scene. So in such cases, what would be your like if you're willing to build GTA or a game like that, what would be your approach to game optimization? Let's keep a miniature scene now, and I'll be going quite rough with this, quite like very informal while explaining this. Uh, like I won't at all be technical. Uh, so imagine you're building a GTA-like scene, and this is our miniature scene in GTA. Is it visible to you all?
Yeah.
Like, is
Yeah.
it like totally crystal clear? Good. So in this case, you want multiple colors to be there on your buildings. So if you have multiple materials on your for your game objects, it is fairly going to look something like this: material one, and then material 2, and then material 3, and then material 4, and like thousands of materials. If you When you're working on projects, and if you just click on this little uh, like filter for all materials, you'd see like thousands of materials you have made. So if I create the scene like this, let's set it to green or something, and then this has blue, and this has yellow, and let's just apply it randomly on top of each of these game objects. So this is a miniature scene. This will not cause any trouble, right? This will not cause any trouble on your CPU. But just for your sake, imagine this is a huge city. Like you can zoom out and still see the city. So what would be your approach at optimization? Is that you have multiple materials. What do you do with those materials? Select all the game objects. You need to batch all these game objects. We call it batching. So when these materials are rendering, this color and light is simulated out of these materials. The shader program that is rendering these materials runs with something called passes. So imagine it like a loop. So one pass renders one fragment of a 3D object. So uh, one good way to optimize multiple materials is multiple game objects is making sure that all of these objects are being rendered in a single pass. If they are not, there will be multiple passes, and that is a problem. That is when you know that you have hit the problem, and you will face CPU bottlenecks. So how to batch these objects? There are two ways. There are two ways you can like render all these objects in a single pass. So one is the static batching. You select all the game objects, mark them as stat batching static from the static checkbox, and it is now grouped together. What this thing does is, when you hit the play mode, all these objects together are treated as a single mesh, a single combined mesh, and the rendering happens in a single pass. Okay, what if you don't want to do static batching? What if you do not want to do static batching? You want to resort to dynamic batching, and you do want to know about a different technique, because if you mark this as static batching, you won't be able to move your object in the play mode or something. So like I've marked this as static batching, so I cannot move this around. This is marked static. It won't move around. So what is the workaround for that? Okay, there is no worries. You just select all the materials, and you'll find a checkbox on your material called enable GPU instancing. So this is a goal for you. This is the goal checkbox for you. You mark this as enable GPU instancing for all the materials, and like if they are applied to the shell mesh, if they are applied to different meshes, they will be treated together. They will be rendered together. So that is one way to go. And what else? Always make sure when you're modeling, or when you're modeling a mesh, or when you're modeling a 3D object, never ever have it in the form of separate 3D objects. Right now you can see separate 3D objects. So never ever have separate 3D objects. Try to have as many shared materials as possible. What are shared materials? So in Blender, if how many of you are Blender users? Should I take the name? Would it be like okay
I'm
for
a Blender user?
Yeah. Okay. What about the rest? Like is it appropriate to go and like explain it? Okay, great. There are Blender users, so yeah.
Yeah.
Okay, no issues. I'll still explain. So when you're modeling in Blender or Maya or any 3D application, you would want to have separate colors on the faces, right? And in Blender, you can do it in the edit mode for sure. You can have multiple materials and then assign it on the faces of different objects in the edit mode, right? So in that case, your object will have shared materials, which is displayed in an array here. You can go down to the mesh renderer, and you'll find some more materials here. See, and they are replaced like element 0, element 1, element 2, like that. So having shared materials is a real good indication that your game is already inclined towards the basics of optimization, or at least the graphical one. And yeah, so the main thing is reducing the draw calls. Batching objects together means rendering the entire scene, rendering multiple geometries, treating them as a single mesh. To reduce draw calls is the main thing. When you reduce passes, you reduce draw calls. And that can be done with static batching, that can be done with GPU instancing, that can be done when you have shared materials and then GPU instancing, or shared materials and marked batching static. It is always good to have a mesh with multiple shared materials than a mesh divided with objects having separate materials. And when you are texturing, suppose this is going to be a texture. If you are texturing a city, if you are texturing like a big thing, try to have it as texture atlas. try to make a texture atlas out of it. And the way to do it is like combine all the game objects together. You make the scene in you guys know the FBX exporter?
Yes, I guess I've
Yes.
explained FPS Explorer.
So you make the scene in Unity. Yeah. Pulkit Meera raised hand. You want to ask something? Pulkit has a question.
I think he
Please
must
feel free to
know.
ask. This is a okay.
I think
This is
he
a
must know
like
for Blender
like
user.
flowing. Okay. So yeah. So the thing is, not having separate materials for objects. Having multiple materials attached to the same game object is the main focus here. So if you're a Blender user or a Maya user, your focus should be that. And about texture atlases, you can make the scene in Unity and then take it to Maya or Blender or like format like from the beginning, model it like that, model the entire geometry, UV map, make the UV maps, and then create a texture atlas out of it. Texture atlas means a texture for the entire city, rather than having materials for each building, each fence. So texture atlases are a great thing. And so you can note these points down. That is reducing the draw calls by static batching, GPU instancing, and then having shared materials and using texture atlases. And then comes reusing textures. How creative can you be while you are reusing textures? How creative can you be while you are reusing normal maps? Having a copy of texture for each separate object, which is similar, which is similar, or while designing games, not every object is visible, right? So there is a clear and crisp visual design associated to each an object that is in the scene. So if you are making a top-down game, and if it's a small asset, if it's a small can of water bottle or a drink can, you want to show it, it would appear really small. No need to use normal maps for that. No need to use separate texture for that. And when you're making garbage kind of visuals, or garbage scenes, when you're making scenes having like a pile of garbage or dust or all of that, try to have a texture atlas for the entire pile, without having textures and normal maps for separate bottles, cans, and all the objects spread out. So my way to go is you group it out. You have one texture atlas for your props, the ones that are static, and then you have a separate texture atlas for your other static geometries in the scene. And so has anyone ever worked with the texture atlases before? For sure you have. Akash has been working on a VR scene, and he would know a lot about it, right?
I think
Yeah.
so.
Yeah. And any leads from have you been using texture atlases, or do you need me to show how it looks? Totally fundamental knowledge, just for clearing it all out. Okay. Now, culling. Let's come to culling. Since you guys are programmers as well as artists, let's come to the programmers first. There is something in Unity called the culling API. How many of you know about it? How many of you have discovered it, used it?
The occlusion culling.
How many of you have? No, not the occlusion culling. There's a culling group API in Unity. This is for programmers. This is for programmers. I'll come to the artist. I'll come to the occlusion culling and all of that. But if you programmers do not know about the culling group API, this is something you should get right now. So what is the culling group API? The culling group API gives you a set of functions that like are called when objects are appearing in your scene, disappearing out of your scene, coming close to your objects in a certain distance. They give callbacks. The culling group API raises callbacks, and this is amazing if you're developing a shooter scene or like anything. Like you can have the entire control on what you want, like which objects to update in your scene and which objects not. For example, if you're having like a huge map like a battle royale game, and there are like lots of enemies spread around, and you do not see them entirely like when you're watching them. So you can use the culling group API to like totally disable all the updates, all the animation updates, all the animator objects, the total game object updates. So using the culling group API is with the logic that if they are not in the scene. Second, you can activate animators. You can activate animation on an object only when it gets close to you. These are like tricks that you can use to like spice it all up, and this would give you some amount of extra work that you need to do. I'll just type it out in the chat. It's called culling group API, and this is something. This is fun. If you check it out, it would be fun. And you'd find the documentation there. There are not many tutorials associated to it, but sorry, I sent it to Khagendra. It should be to everyone.
Yeah.
Sorry. So it does not have like a lot of tutorials online, but you can surely like follow the documentation. Next, coming to occlusion, there are two kinds of occlusion in Unity if you want to use it. Can you name it? Yeah, one is the frustum culling that comes from your camera. So when your camera is looking around, let me just reduce the field of view. So you see this. This is the frustum of a 3D camera, right? This white line spreading out of the camera, forming a shape. This shape is called the frustum, and anything that is within the shape or any plane is any plane here is the viewport, right? So anything that comes within this frustum, anything that steps within this frustum is rendered as your on your viewport as your game view, right? So if an object, if a part of this object is within this frustum, it will get rendered. If it is not, it will not. So this is the main logic of frustum culling. So if you look at closely, these lines are intersecting the plane here, right? So this part of the plane which is out of the frustum, which is like hidden from the frustum, would not be rendered, and that is called frustum culling. However, in frustum culling, part of the objects that are hidden by other objects, which means this object is in the frustum of the camera, this object is in the frustum of the camera. The frustum culling won't hide this part of the object. You see this box, a small portion of this box is hidden by the box in front of it. It will still be rendered in frustum culling. So that is when you need to choose something called occlusion culling. And to do that, you would need to select the objects you want to bake into occlusion and select them and mark occluder static. And then go to window, and then from from rendering, you can find occlusion culling. So once the occlusion culling window appears, you can bake the occlusion culling, and you can see, you can set some parameters like the smallest occluder, like what is the size of the smallest occluder, what is the size of occluder in scene units that is going to hide other objects. Right now it is 5, which is too big. So let me just reduce it to 0.5 or 0.2 for a scene like this. And this can be the size of the like largest object that you want to use to hide. So right now the unit is 1. So let us use 1, and let's bake. Or let us even reduce it to like this 0.5. Yeah. So this one is a good. Still not good enough. So make sure that it is the better, like the more of these little blocks out there, the better the occlusion culling. So if you view the volumes right now, visualize. Let me select the camera out here. Yeah. So right now, what this camera is doing is like throwing rays out, and parts of this mesh is being hidden. So this occlusion culling, this baked occlusion culling, would hide the faces, hide the like wireframes or the like meshes that is being rendered here. So that is where occlusion culling gives you an extra layer of occlusion from the normal frustum culling that is already like built in Unity. So you don't need to like do anything about it. This is the bake information. So right now, if I play it, still this is not the right scene to like display it. You can see the occlusion like bake in working. So when the frustum is moving out, it's like hiding the things. It is rendering only things that is relevant. Still, this is not a good thing to like give an example with, but what I wanted to make it as a point is that put occlusion culling first before the normal frustum culling that is like default with your main camera. Any questions till now? Any questions?
I don't think so.
About setting up of the parameters. Yeah, as you can see, you can select the smallest hole that will be used, and this should be like lesser than the occluder, and like the smallest hole that you're going to use to like hide other faces, like this. There is never a perfect or sweet value. This is totally like based on how you want to do your scene. And let's move on to the next one. Let's move on to the next one. About profiler, about using profiler. Let's access the profiler first. So you need to play the play mode. You need to go into the play mode, and then window, and then analysis, and then profiler. Under the analysis tab, you'll find the profiler. The profiler is like like constantly reading your scene and giving out feedbacks on how is it working. And what you need to do is you need to select and check the peaks. What is this peak coming out from? What is this peak coming out from? You can change the view. You can change the view from timeline to hierarchy. and this is better. This is better for programmers if you see it like like in the hierarchy format. So you know that what is taking most of the it is what is the like self consumption of each of these like parameters. So right now you can see that there is no like behavior or custom behavior running out. So you can like pretty much ignore that. What comes under the player loop, and the player loop is the application that is playing the player. I mean, not the character or a player. It is the game player that is the application that is streaming the entire game. So in the player loop, it has the camera render and then the physics updates, and so it is ranked based on what kind of consumption it is like using. What is the self consumption of it? And there is this garbage collection allocation, which is like definitely very annoying, because if you have been like running your game for a while and you suddenly see your FPS drop, blame it on the GC, blame it on the garbage collection. That's none of your fault. So you would need to like devise or design your game or design your code like that, so that you can have less GC, less garbage. So manage it your own way, and that is why object pooling is necessary, and a lot of other ways to do it. And now, so that is how you use your profiler and like search about it, read about it. Another way, another great part of optimization I would like to mention is that reduce your texture size whenever necessary. Any question? Anything?
I don't think so. Can you mute Binoy? He's, I think, talking to somebody else. Yeah, I think it's good.
Okay. Okay. No issues. So what I was saying is reduce your texture size whenever necessary. If you don't require, how to understand that you need to reduce your texture size? I'm looking at the game from this side, like this view. Like if I'm looking at you, like if this is a top-down view of your game you want to have, and if there is an object that is like just capturing 256 cross 256 of your pixels, definitely have a texture lower than that, lower than that resolution. Like reduce your textures, reduce the resolution of your textures whenever necessary. And for normal maps, for everything, this is really important. Like reduce the texture resolution and compress it properly. And then comes audio. So how do you select like the right settings for audio? So let me just import one. Do I have any audio with me? Import new asset. Yeah, I have one. So selecting the proper, like choosing the proper, compression and load types for your audio is really relevant and really important. If you are making games with like lots of audios and like lots of sound effects and all. So how do you do that? Definitely check load in background, or this is like preloading the data, and then decompress on load. Make sure this is checked. And then selecting the compression type, selecting the compression format. Make sure you can refer to ADPCM. It is like, so ADPCM is like 3.5 times smaller than PCM. And you can like select it whenever you want it. Like you can choose it, you can prefer it other than the Vorbis and PCM. So you need to figure out if there is a crisp and clear noise, if there is a crisp and clear audio, which you definitely don't want to spoil, don't compress it. Where can you compress it? For sounds with lower volume and for background sounds, for all the sounds that you as a designer feel that it has much less effect on your scene, on your player, or on the mood of the game. So compress that properly. And this is the whole point of optimization is it is never one thing. It is a lot of things together. Now, coming to streamlining physics calculations, how would you streamline physics calculations? You definitely know that raycasts are heavy, and I would like to rule out a myth if you have been following it. A lot of code doesn't mean your game is going to lag. More code does not mean your game is going to lag. Rule that myth out. Proper coding, proper ways of coding is what we are focusing on and what we should focus on. So what can we do to manage that properly? So this is how a basic beginner script looks like, right? Well, when you create a script, it looks like this. In the update, you write input code. Can you see my visual code? Sorry, or do I need to switch the window?
You need to switch
okay, I'll just switch the. Okay, well, now.
Yeah, it's visible. Your code is visible.
Yeah. Okay, let me just zoom it up. So this is what you would find when you create a new script or something. So in the update, you would generally prefer to take the inputs, and then you would have the fixed update for your physics calculations. So what is this physics calculations at first? This could be a raycast. This could be a collision detection. This could be a rigid body related function, which is running in fixed steps, which is updating in fixed steps, or physics steps, you would call. Fixed step is the time where the physics engine is updating its loops. So you need to optimize when your physics is being called. How to do that? A great way to do that is you write a boilerplate code for that. So what you do is create a float, we call it time or something, and or I would call it TOE, time of execution, TOE. And then what you do is in fixed update you increase this with fixed delta time, and you have a constant variable. You have a constant variable, call it threshold, and let's call it 1 second or one a value of 1 unit. And then when TOE, if TOE is greater than the threshold, then only execute this block of code. Execute this block. And this might have calculations that you do not require in each frame. Calculations not required each frame. You have to now decide this is totally game dependent. This calculations I'm talking about is totally game dependent. Another way of doing it, this is the an informal way to do it, but what is the another way of doing it is having coroutines. scheduling coroutines, writing your own updates. So the code, the block of code goes like you create a function which returns a type called an iterator or enumerator, and call it my custom update. And then within that, you write a while loop. Let's write while true, because you want this loop to write infinitely. You want this loop to write infinitely when your player is playing the game, and because custom updates are supposed to run infinitely when you start them, right? So now this while block would execute only when yield return new wait for seconds. Now when writing this block of code, you'd come with a fork. You'll hit a fork, and you'll find that there are two ways to do it. One is wait for seconds real time, and the other one is wait for seconds. So the wait for seconds is the seconds updated by the Unity engine, which is not the system time, which is not the system time step. It is updated from your frames, from your which is delta time dependent. And wait for seconds real time, on the other hand, is like proper system time, which means if I put a value of 2 after writing wait for seconds real time, it would actually wait for 2 seconds before executing another loop, right? But if I write it like wait for seconds, it would wait for this value to be hit by delta time. So if there is a counter variable which is like constantly adding up delta time, if this is greater than 2, then execute this loop. This is a great way to boilerplate your code. And then you need to start this coroutine by calling start coroutine, and then call it my custom update, like this. And there we go. So here you can do a physics calculation or something. Now there is something more you need to check. There is another return you need, which is you want to wait for the physics step to complete. So I'll hit another thing, new, wait for fixed update. I'll write this line, and what this would do is it would wait for fixed update to complete, and then it will fall to this line, wait for 2 seconds. It will again execute the loop, wait for fixed update to complete again. So in this way, this coroutine runs in sync with your fixed update. So this is a great way you can optimize your code or optimize your physics code. And this is really important when you're making a huge game. This is only a basic thing I'm showing you right now, but there are a lot of ways to do it. And this is one of the ways I really love while coding, optimizing my code. Now, so you can understand that cast array whenever it is required, but don't keep it updating thousands and thousands of arrays together. And when you're making client systems, when you're making something really heavy on the computer, which is really a collision system based on, don't force on your computer. Boilerplate your code. This is one way to boilerplate your code. And using layer masks when you raycast. You guys know about layer masks, how to set up layer masks properly. If you say, if you want me to show it, I'll show it, or else I'll skip it.
Yeah, I think you should show it. We know how to set up a layer mask, but
Okay.
what should be the optimal way of doing it? That's the optimization part, right?
Okay. The if you do know, so there is no optimal way, I'd say, but do use layer masks. Layer masks are really important if like when you're doing it. So there are like a lot of ways to do it, and where do I start from? Let's if you are making a shooter, if you are making a shooter, uh, make sure that you have a layer mask uh, called as like I would do it. What I would do is, let me go back to my scene in Unity. Uh, can you see it?
Yeah.
Yeah. So what I would do is, while making a shooter game, I'll create a layer and call it affected. Affected, and then I'll create another layer and call it detail, hit detail, or something like hit detail, because setting up a shooter is all about, like a good shooter is like if you're only properly raycasting it out. And not only raycast, you can use a lot of, like, if you're using a box cast or a capsule cast, you need to like properly set up the layers. So what I put in the affected layer is all the objects that I want to, like be affected, as a like maybe a bullet shrapnel. So it can be a wall where I want, like the bullet to make a mark on. I'll put all these like other objects, all these NPCs, sorry, all the like objects other than NPCs within the affected layer, and then put all the NPC colliders within the hit detail layer. And then there's another technique you should be using, which is go to project settings, select physics, uncheck everything. Uncheck everything when you're beginning in the project. So what this does is it makes sure this is the collision matrix. This is making sure which layer collides with objects with which layer. So if this is checked, it means default and hit details collide with each other. If this is checked, default objects in the default layer collide with the default layer. A very good way to optimize your physics is unchecking all of that and then leveraging on your own. So if you create like a layer called as ground and a layer called as player, you would see it here. Uncheck it, uncheck everything. Just make sure ground and player are checked. Ground and player, this is checked. Customize your collision matrix. Customize your collision matrix. It will save a lot of physics update. And let's move on to another thing. We are short on time. We can still finish it off. Yeah. Collision, the most fun thing to do. And I'm not talking about just setting up box colliders. What I'm going to talk about is do I have a proper mesh to show it? Let me check. I don't think. Let me use it from my that flight simulator I was working on. Okay, so I have this Boeing FPX model. Import. So I have this flight model, which is pretty big. Can you see it?
Yeah.
Yeah, it's pretty big and wide. So if I go into the shaded wireframe view, it has a lot of, like wireframes and all. Like it has a lot of meshes. There's a lot of lot of triangles. The mesh is made up of a lot of triangles. What if you are willing to build a collider for it and not, like if you use capsule colliders or box colliders, you'll have blind regions that won't collide, or you'll end up with a lot of margin for collision. And if I don't want that margin for collision, what I do is you port this thing, you take this entire mesh to your 3D editor, a Blender or something, and then create a separate mesh and call it collider. So here, like I have made something, wait, it's importing. Yeah, so I'll create another mesh for this detailed object and call it collider. You see the triangles of this collider. This is the collision mesh that I'll be using for this airplane. Can you see the difference? Can you see the difference?
Yes.
What? Okay. Yeah. Yeah, the plane seems familiar. It's the same plane that I was flying a few days back, and I have crashed it multiple times. And so this, what you would do is you just check it and add a component called mesh collider. Mark it convex for each of these meshes. So you have an optimized collision here only. So for all of your objects, you can do that. Having a lower resolution mesh as a collision mesh for your game objects. And then we have rigid bodies. It's always good to like customize your rigid bodies. So when I talk about customization, like have a script that controls the sleep and awake state of rigid bodies, and switch them on whenever you need them. You need a rigid body manager script, and that is why I gave you the culling group API, which you should be looking at. And the culling group API would give you all the callbacks that you should be using to turn on and off your rigid bodies whenever you do not need them, or based on your need. And then when you're instantiating multiple objects, next comes the object pooling. When you're instantiating multiple objects in the scene, instantiating and deleting multiple objects in the scene, like footprints which are not particle system based, or bullets, or player or characters, or like enemies or something like that. Keep a like object here. Keep an empty game object. Call it object pool. Object pooling is very easy. Like, have you been using it? Like, have you all been using it before? Yeah. So okay, yeah. So object pooling, what you do is you basically like pre-instantiate the prefabs. So if you have this, if I'm going to like instantiate this plane 100 times, or like if I'm going to instantiate or destroy this plane constantly within the scene, what I would do is put this in the empty game object pool, make a copy of it 100 times, make 100 copies of this Boeing aircraft and disable them, and keep them all disabled. And when I need to instantiate them, I just enable the one I need. So in this way, here instantiation means enabling the object, and destruction means disabling the object. So what you need to do is you write a script for preloading the game objects. You basically, in the object pool, you preload all the prefabs on a set number of times, maybe 100 or 200, and the number is based on how many times or how frequently are you instantiating or destroying this game objects. That is the basics of object pooling, which is keeping stuff instantiated, and then disabling or enabling object. The language of instantiation completely changes when you're using Objectfully. I have told you about coroutines, and now there is caching. How could I forget? How can I forget caching? So I should have been like telling about it when I was like discussing the coding part. Caching. I want a component. I want a component from my game object. I'd make sure it's preloaded. These are some of the functions that would destroy your update if you do them repeatedly. One is get component. Second is game object dot find any version of this, any like extension of this, and then yeah, some very heavy calculation, some gibberish, some pretty heavy calculation. If this is running in a like constant update, boilerplate it like coroutines using your own custom updates, and you can take a screenshot of this, of how this is executed. And yeah, there are more like raycasts. There's a huge list. There's a like huge list to it. Then what I should have listed it beforehand. My bad. So yeah, there's a like huge list to it, but these are something that you need to like figure it out. Search operations are heavy. If you learn about the various algorithms that are being used, you'll find that the search algorithms are heavy. Loops are heavy. Combining loops. How would you optimize your loops? If there is like a 3-nested loop scenario, how to optimize that loop, how to use recursion, how to use function recursion whenever necessary, whenever possible. These are a few things that you should be careful about. So yeah, cache your objects, cache your components. So never call it like here, if you are like taking in the rigid body or animator, I've seen developers do like get component whatever animator, and then like set float, blah blah blah. This is the wrong way of doing it. This line is going to destroy your updates. How many of are using the Rider editor, like to write code?
I'm using.
Is anyone?
Code.
You're using
VS Code. I'm
no,
using
not
VS
the
Code.
VS. Okay, the Rider. Yeah. So if you're using Rider, it will like point you out that hey, you're doing this wrong. Hey, this is going to slow you down. So that is a great like code editor that you should be like using. Just take it out. And then we have then we have like two more things that I want to tell, and this is something basic. You have been using it all the way. Use mixed and baked lights. Can I have the microphones on mute?
You can mute.
Can I have the microphones on mute? Yeah. So JetBrains Rider, yes. Yes. Another thing is bake your lights. Bake the entire scene. Bake the F out of your scene. Baking is the way. Bake as much as you can. Use mixed lights. Use baked lights in the lighting section. in the lighting section, if I go to the lighting settings, you can see my window. Unity?
Lighting window is yeah, now it's
Yes,
visible.
Yeah. So you see in the mixed lighting mode, where there is this lighting mode, this is the most optimum way to do it, baked in direct. This guy will save you from a lot of headaches later. So as I'm saying, your optimization should be a part of your design. Don't ignore it anytime. If you are making game, putting out ideas, don't do it. Hold back anytime you need to optimize your game. And this has to come with a very, very clear eye to detail, a very clear eye to, like a very receptive eye to, like understand that whether you're going in the wrong direction. And then comes LODs. LODs are something really pretty. If like the Boeing thing, if I am using this plane and I see there's a lot of wireframe out there, I need to have a LOD. So I can like add an LOD group, and then what I can do is like anyways, yeah, I want to do it card here. I want to do it here again. Where are you? Yeah. Basically, what this is doing is, okay, let me show you from here. LOD. You see, when I'm going far away, it would basically show the, it will recalculate, it has its own recalculated meshes, and what here are the renders actually. So what this would do is, when I'm this close, I would see the details, and when I start moving away, the wireframe starts reducing. The details, the entire resolution of the mesh starts reducing. And you can have multiple meshes and multiple models. You need to have multiple models for these LODs. So there would be a model for 100% LOD. There would be a model for 78%, and there would be a different model for 30%, and there would be a different model when it is culled. It can be an image. This 10% thing, it can be just an image. So this is another way to do it. This is a like great way to like save your draw calls and all. And there is something that I would say, but we are like short of time, so I won't be able to explain it. Which is animation instancing, which is using your skinned mesh renderers properly. Skin mesh renderers would cause a lot of trouble. Multiple skin mesh renderers with multiple bones is a trouble. So you study about animation instancing. That is something you should be looking at. And this is important when you're working with large amount of characters, a large amount of animators in the scene. Anyways, let's wrap it all up. There are a lot of ways to like optimize your game, and what I mentioned today is just like not even a percent of it. It is optimization is a lot more than it like sounds. Like it is not as easy as I made it like appear. So there's a lot of things. It is within the design. It is how close and how familiar you are with the editor, how good you are with the editor, and how good you know how to manage things with the editor. And there's a lot of things going around when you're optimizing your game, right? Which is writing your code properly, set.
Aritra, are you there? Your voice is not there. Aritra, you are not audible.
Hello.
Yeah, now you're
Yeah,
audible.
I'm sorry. Like my voice went away. Because we are having a thunderstorm here, and like I'm facing some
Okay.
trouble with the internet. Anyways, guys, wanted to wrap up. This other few basic things I wanted to like share with you about optimization, and since you are participating in the jam, it's like it should be like helpful for you. Now it's time for us like small Q&A, and if you are willing to, like give a feedback on whether you love this session or not. Was it good enough? Was it informative enough? Do you want it to do like? Do you want me to do it again? Like go into more details? Then yes. Today's topics: Texture Atlas, Culling Group API, Occlusion Culling, Profiler, and GC using ADP writing boilerplate code as well as coroutines, optimizing collider matrix, collision matrix. That's collision matrix using object pooling, caching, and animation instancing. It was awesome. Okay, I've got my feedback, and thank you, Aman, for like listing it all out. Like I myself didn't have a list, and so like it feels really good. Uh, anyway, thank you everyone for joining. And if you're making a game for the jam, I'm like totally excited to play it out whenever the entries are coming. We are closing the submissions on 23rd, and I hope you're enjoying it. Okay, it was really good today. Yeah, okay. Great. That's great enough. If you want to do this session with more of your friends, let me know. I'm up for it during the quarantine. I'm having a lot of time out during the quarantine, so I won't mind doing it again. Okay, so thank you. Let's wrap it all up. Let's end it here. Have a safe quarantine. Have a great game jam. See you again.
Yep. See you guys. Good night.
See you guys. Good night.
Was there a question or something?